had a different risk. A non-smoker had a different risk. This model assumed that the risk changed when you move from non-smoking to 1 pack a day smoking, or 1 pack to 2, or 2 to 3. It didn't necessarily change linearly, because notice these coefficients, D1 and D2 and D3, didn't all increase by the same amount. Actually, D3 was a negative number. While in the second model, the last model we looked at, we assumed a linear relationship. So making assumptions about models are crucial. Making correct assumptions are crucial. In the coming weeks, we'll be talking about how we can help decide the best way to represent risk factors in models. But I think, for the first time since we started this, I've covered everything that was in the handout, with 3 or 4 minutes to spare. So the good news is you have 3 or 4 minutes to relax now. There's nothing new to present. Again, all of this is meant as an introduction. We'll see a lot of it again in the coming weeks. So for you who are just learning statistics for the first time, and this might seem a little bit more complex, hang in there. You'll see it again, these same issues coming up again. For those of you who have had courses in statistics, all this should have been a review. Maybe would have been boring to you. And next week, we'll be talking predominantly about logistic regression modeling and what we can do with those types of models. So you'll see maybe some new information reported then. If you have any questions, feel free to send me emails again, or you can try typing an email now. But as I say, it's getting near the deadline of be disconnected. So if people have questions, I'll be happy to hang in there and try to answer them now, or you can send me emails later. Otherwise, I'll bid you a good morning or a good afternoon, depending where you are. It's getting near dinner time now out here in Massachusetts. And remember, the important point for the next time we meet, which is November 3rd, I'm still going to be talking from 4 o'clock here in Boston. 4 o'clock here in Boston is going to be a different time in Hawaii next week. So you take that into account. Okay? Erin, do you have anything to add? I see my microphone's on.
Nothing more to add, Fran. Just everyone, there's no homework this week, but I'll be sending out the links to the course, the recorded sessions. And I think Patrick has a question.
Yeah, I see the question. For question 5, you prefer the Wilcoxon over the t-test. But isn't a parametric test always better than a non-parametric test? Let's go back to that question. That's what I'm talking about. And I apologize, Patrick, for not analyzing this. First, I'm going to give you a little story. And we're getting there. Come on. When I was studying for epidemiology, writing my thesis is and Erin, can I ask you just to turn your mic off for a second, because I'm hearing myself when I'm talking. Thank you. You can turn it off when I finish. My thesis advisor once said that the only thing he ever did with tea was drink it. Namely, he never did a t-test. He always did non-parametric tests. And Patrick brought up a very good point. I'd like to question 5 if I could. Can I go by it? 2 by 2 table? No, that's not it. Then Nate labeled it. That was, I'll get back to it. Small study, defining measures, small studies on the... Okay, which of these following tests of significance would be the most appropriate for comparing length of stays? Let's just focus on these 2 tests. Test number 2 is a t-test. That compares the average length of stay in one group to the average length of stay in the other group, using means as averages. And the Wilcoxon test is based only on ranks. It says, let's rank everybody from lowest to shortest to longest length of stay, and see if the average ranks of the people in one group are different from the average ranks in another group. And I mentioned that means. Patrick has brought up a very good point. When the outcome you're measuring is normally distributed, in other words, let's suppose length of stays are normally distributed. They don't have this tail of a few people having atypically long length of stays. So let's suppose if you drew a histogram of the length of stays, each of these 2 groups you're comparing, they would have this nice bell-shaped normal distribution. And it turns out the most powerful test you can do for comparing those 2 populations is a t-test. So it's agreed when the populations are normally distributed, that you're comparing, t-test is the most powerful test you can do, the most efficient test. It gives you smaller p-values than any other test. It turns out that the Wilcoxon test is not as powerful, but almost. Meaning, if it has what is called something of the order of 95, 96% efficiency. Meaning, if you did a t-test with 96 people, it would be the same as doing a Wilcoxon test with 100 people. You have to use a few more people to get the same amount of power, but not a whole lot more. I also mentioned if the length of stay is not normally distributed, then the t-test may no longer be the most powerful test to consider. But if the sample sizes are large, it tends still to be the most powerful test. So there are two situations where I would agree do the t-test. When you have normally distributed outcomes, regardless of whether it's a big study or a small study, or you have a big study. But if you have a small study, you have data which you suspect are not normally distributed, like length of stay, that's where the Wilcoxon test might actually be better than the t-test. That's why I would say probably for small studies with skewed, non-normal data, my answer would be 3. So, Erin, you can turn your mic back on now if you want, but that was my justification for trying to look at answer number 3. But in general, t-tests are better for analyzing large data sets or when you have normally distributed data. Patrick, I hope that at least gives you why I chose that for an answer. Other people might disagree, but at least that was the motivation for that answer. Okay, guys, it is after 5:30 my time. I wish you all a happy Halloween. Going to Friday night. Please enjoy yourself. Send me an email. Tell me what costumes you had. Maybe we can see if anyone had a good costume. But otherwise, next week, remember, different time out in Hawaii. Same time here in Boston. Unfortunately, this time next week, it'll be dark here in Boston. Downside of turning our clock. We wake up when it's still sunlight for the kids to go to school. It starts getting dark a lot earlier. So I'm going to hang on for a few seconds in case Erin has any questions. And I'll bid you good night or good morning or good afternoon to everybody else. Have a great time. And next week we'll be talking about logistic regression models.